Okay, for the very last section that we cover in college algebra, chapter 5, section 6, we are graphing inequalities, systems of inequalities. And the first question, we're asked to graph the inequality x minus 3y is less than or equal to 9. Now the way we graph a linear inequality is to evaluate the inequality by solving for y. We want to solve this whole equation for y, and then we're going to get it into this form over here. Either y is greater than mx plus b, y is less than mx plus b, y is greater than or mx plus b, or y is less than or equal to mx plus b. Now these are from the course notes. You can find those on Blackboard. Now anytime you have a greater than or a less than sign without the little equal sign underneath, we're going to be using a dotted line when we graph the line. If you have a greater than or equal to or less than or equal to, we're going to be using a solid line. If the equation can be written, or the inequality can be written as y is greater than mx plus b, or y is greater than or equal to mx plus b, you're going to be shading above. Think of greater being higher, so you shade above the line. If the inequality is in the form of y is less than mx plus b, or y is less than or equal to mx plus b, in both of those scenarios, you're going to be shading below the line. Think of less than being lower than, so you shade below. Now, if the inequality only has an x in it, that means your line is going to be a vertical line, and you're either going to shade to the left or to the right. All right, so let's get back to this problem here. We want to solve this inequality for y. I'm going to subtract x from both sides, and then that will give me negative 3y is less than or equal to negative x plus 9. Now, the next step, I'm going to divide the inequality by negative 3. Remember, when you are dividing an inequality by a negative, the direction of this inequality is going to switch. Right now it's a less than or equal to. When we divide by the negative, it's going to switch to a greater than or equal to. So our inequality becomes y, when we divide the negative 3's, the less than or equal to is going to change to a greater than or equal to. This is a negative 1 x divided by a negative 3. That's the same thing as 1 over 3x. And then the 9 divided by negative 3 is minus 3. And we subtracted x from both sides of the inequality, then divide by negative 3 on both sides of the inequality to solve for y. Now you can see we have it in the form of y equals mx plus b, but as an inequality. So again, where we have this m, the slope of the line is going to be 1/3, and the b, the y-intercept, is negative 3. So we can graph the line, and it's going to be a solid line because we have a greater than or equal to. So again, it's going to be a solid. The slope of the line is 1 over 3, and the y-intercept, b, is negative 3. So we start graphing the line at negative 3, plot your point, and then I'm going to use the slope to go from there up 1 and to the right 3. Now when you do this on the homework, you only need to plot those 2 points, the y-intercept and one other point. You can make a table if you have to. So once you have those 2 points, you will draw the line straight through those. I'm going to plot a few more points so that I can get a nice straight line to go through those. Okay, and then I'm going to pick up my line tool here. And draw the line right through that. The next part we get is the shading. We need to determine if we shade above the line or below the line. Since this is in the form of greater than or equal to, in this case we are going to shade above the line. Just think of shading higher, above, it's greater. So I'm going to use the shading tool here, highlighter, and just shade everything. Now what this means is that the solution to the inequality are actually all the points that are in the shaded region. Actually, there's an infinite number of points. So instead of listing out all the different points that are solutions, we shade everything that is a solution. All the points that are in the shaded region, as well as every single point on the line, is a solution to this inequality. On the homework, I'm going to pick up the line tool and I'm going to plot the y-intercept of -3 and then move up 1 and to the right 3, and I draw that nice straight solid line. Now I'm going to pick up the paint bucket here and I'm going to pour it in the region that you want to fill up with color. In this case, it's above the line. I'm going to save and check my answer. Okay. So the way that we go about solving these inequalities, what I do is I solve the inequality for y, and then it's in this form, y greater than or equal to, it's a solid line shaded above. Use the slope and the y-intercept to plot a few points on the line. Okay, let's look at number 2. Number 2 is a lot like the one we just did. Let's go about solving the inequality for y. I'm going to subtract, actually, I'm going to add 6x to both sides. I want to get the y by itself. And with that, I get 5y is greater than 30 plus 6x. I'm going to write it as 6x plus 30. Now I want to divide by a positive 5. When you divide by a positive 5, it doesn't change the inequality. So we get 5 divided by 5, we get y. The greater than sign does not change. The 6 over 5 is your slope, 6 over 5x, and 30 divided by 5 is positive 6. So since it's in the form of y equals mx plus b, the slope of this line, the slope is equal to 6 over 5, and the y-intercept is equal to positive 6. I'm going to plot a few points, starting with the y-intercept of positive 6, and then using the slope of 6 over 5. I'm going to move up 1, 2, 3, 4, 5, 6 over 1, 2, 3, 4, 5. And then I can move in the opposite direction, 1, 2, 3, 4, 5, 6 over 1, 2, 3, 4, 5. And you can keep going. Now, because this is a greater than sign, it is going to be a dotted line. And we need to decide whether we shade above the line or below the line. Since this is a y greater than sign, we shade above the line. Just a quick shading like this. So the solution to this inequality are all the points in the shaded region if this graph paper goes on forever, as everything in the shaded region, not including the line. If it's a point on the line, it doesn't satisfy the inequality. That's why we use a dotted line. Let's graph it on the homework. You pick up the line tool and I'm going to plot the y-intercept is 0, 6, and then the slope of the line is 6. So I'm going to go up 6 over 1, 2, 3, 4, 5. So that point 5 comma 12. 5 and 12. Okay. Now I'm going to change this solid line to a dotted line by selecting this little dashed line feature right there. Then I pick up the paint bucket and I click on the region that I want to shade. So everything above the line, since it's y greater than, and save and check your answer. again, the key to doing these is to get the y by itself. If you refer to the instructor notes, you see that I've kind of broken it down here, when to use a dotted, when to use a solid, when to shade above and when to shade below, or even when to shade right or left if the inequality only has an x in it.